All right, this is Honors Algebra 2 Pre-Calculus. We're doing 7.3 in Algebra 2. This is our third video in the section, and it is on synthetic division. So synthetic division is a shortcut that works for linear divisors, so it's a faster way to do long division of polynomials. While it's possible to do synthetic division with nonlinear divisors, it gets really, really ugly really fast. I want to make that point that it's not impossible to do synthetic division with nonlinear divisors, but it's really not worth it. I believe at one point early in high school, my teacher said that it was impossible to do it with nonlinear divisors, and I thought she was probably wrong, so I did some math to see if she was wrong, and she was in fact wrong, but it definitely wasn't worth it to do synthetic division with nonlinear divisors. So let's walk through how synthetic division works. So what we're going to do is we're going to take the divisor, which is right here, right? Take our divisor. We're going to set it equal to 0. So the first thing I'm going to do is take my divisor and set it equal to 0 and solve for x. So I get -2. Now that number is going to go in the top box like this. Then I'm going to take the coefficients of the dividend, right, which are 1, 5, and -3, and write them across the top of the big box. So set the divisor equal to 0, put it in the top box. Write the coefficients across the top in standard form with placeholders of the big box, which I did. And then below the bottom, the last coefficient in the big box, write the remainder box, which I did. Okay. What I'm going to do now is the steps of actual synthetic division. So all of that was just the setup for synthetic division. Here are the steps. I drop the first coefficient all the way down. I then multiply, write the number in this column, and add straight down. Multiply, add straight down, right? So this is my remainder. And then from the remainder box, I work backwards with the numbers, then the x's, then the x squared. So this is number, this is my x. So this answer is x, because there's a 1x, plus 3, because 3 is the number, plus my remainder over, and then I don't put the -2, I put the original divisor, okay? So if you were to go back and look at our example from long division, this is the same example that we did with long division in a previous video. And it came out the same way, but this is how we do synthetic division. Okay, so let's go ahead and walk through some pros and cons of synthetic versus long division, and then keep doing some example problems. So pros to long division: it always works. It's fairly intuitive because if you remember long division from 4th grade, it's very similar to long division from 4th grade. Cons to long division: it's long. It's called long division. That's in the name. It's going to take a while. Synthetic division, some pros: it's super fast, right? It can be used to factor, which we're going to do later in this video or the next video. It can be used to evaluate a polynomial, which we're going to do later in this video or the next video, right? And then cons: it only works for linear divisors. Again, that's a half-truth. It really does work for nonlinear divisors. It's just disgusting. And if you forget the algorithm, you're in trouble. It's not particularly intuitive. You're not going to be able to logic your way backwards to figure this out. So honestly, both of them have different uses for different things, and it's worth getting comfortable with both, but I just wanted to put up there that each of them is useful in its own way. All right, so let's go ahead and divide with synthetic division. So I set my divisor equal to 0, right? That number goes in the top box. I put the coefficients across the top, so 1, 3, -1, right? And then I drop the first number straight down, multiply, add straight down, multiply, add straight down. This is my remainder, and then I work backwards from the remainder, number, x, etc. So my answer to A is x plus 2 plus my remainder over the divisor. If we go ahead and do B, right, I have x minus 2 equals 0, so x is 2 is going to go in the top box, right? I write the coefficients across the top of the big box, so 2, 3, -4. I drop the first number down, multiply, add straight down, right, so I multiplied these two to get this, add straight down, multiply, add straight down. This is my remainder, my number, my x. So I get that the answer is 2x plus 7 plus my remainder over the divisor. You can see how fast that is and how little work goes into it. It's much faster than long division when it's an appropriate choice. Okay, so go ahead and try P9. You're welcome to pause me if you want. It's okay if you can skip to x equals 3 just in your head by saying x plus 3 equals 0, so x must be a negative 3. So I have a negative 3. My top box has this negative 3, and then I have a 1, negative 5, 2 across the top for the factors of the dividend. I drop the 1 straight down, multiply, add straight down, multiply, add straight down. This is my remainder, my number, and my x. So I get x minus 8, plus, not equals, come on, brain, plus my remainder over my divisor. Okay, and then for the last one in P9, same thing. It's not cheating if you can jump to x equals 1, right? If you set x minus 1 equal to 0. So you're going to get a 1, negative 3, 1, and 5 would be the coefficients across the top, right? Drop the number down, multiply, add straight down, multiply, add straight down. This is my remainder, and then I work backwards, right? I work this way. So I get negative 3x minus 2 plus my remainder over the divisor. So let's do one that's a little bit harder. This one has a placeholder, right? So see how there's no x term right here, right? There's no, so there's no x. I shouldn't say there's no 0x. There's no x, so I'm going to put a 0x there, right? So first I set my divisor equal to 0, so x plus 4 is 0, x is negative 4. Again, it's not cheating if you can get there on your own. So I have negative 4. And then when I write my coefficients across the top, I have 2x cubed negative x squared, but no x's, and that's really important, and then the 3. And my remainder box goes under the 3, right? So this is really important. You need that placeholder there, right? So I drop the 2 down, multiply, add straight down, multiply, add straight down, multiply, which should be a negative 144, and add straight down. So this is my remainder, my x, or my number, my x squared. So we get that the answer is 2x squared minus 9x plus 36 plus my remainder over my divisor. All right, same idea here. You'll notice that there is no x squared, right? So I have an x minus 5 equal to 0. X must be 5, right? That's what's going to go in the top box. But then when I write across the top, I have 1x cubed, no x squareds, right? That's really important that I'm missing the x squared. 2 x's and a negative 3, right? And under the negative 3 goes my remainder box. I drop the 1 straight down, multiply, add straight down, multiply, add straight down, multiply, and add straight down. This is my remainder, my number, my x, and my x squared. So I get x squared plus 5x plus 27 plus my remainder over my divisor. And again, it's much faster to use synthetic division than long division. So, cool. Let's move on from there. Okay, so the factor theorem says x minus r is a factor of the polynomial expression that defines the function p if and only if r is a solution of p of x equals 0. That is, if and only if p of r equals 0. So for instance, if x plus 3 is a factor of p of x equals x squared plus 7x plus 12, then p of negative 3 should be 0. Now we already know that x plus 3 is a factor of that particular polynomial because you should be able to factor that quickly into x plus 3 times x plus 4. But you can confirm that you're right by checking to see what p of negative 3 is. Sure enough, p of negative 3 is a 9 minus a 21 plus a 12, which comes out to 0. So this is super useful information in case we're not necessarily factoring, but rather just trying to find the roots or trying to find ways to factor a polynomial that we can't factor easily. So let's go ahead and do an example. In example 10, we're given a p of x and we're asked two questions. The first one is p of x, does p of x have x minus 2 as a factor? And then justify that answer, right? And then we're going to try the same thing with x plus 3. Well, if x minus 2 is a factor, my bad, we need the pen. If x minus 2 is a factor, then x equals 2 should yield a 0 when you plug it in. So we're going to go ahead and find what p of 2 is. It's going to be a 2 times an 8, right, because it's an x cubed, minus a 5 times a 4, right, because that's an x squared, plus a 3 times a 2 minus a 2. So I'm going to get 16 minus 20 plus 6 minus 2, right? And however you work this out, whether you work left to right, whether you put the positives together and get a positive 22 and a negative 22, or if you work left to right, you get negative 4 plus 6, which would be 2 minus 2. Either way, you get 0. So yes, because p of 2 is 0, x minus 2 is a factor. All right, let's try the same with x plus 3. So if x plus 3 is a factor, then x equals negative 3 should be a root or a 0. So let's try p of negative 3. So when I plug that in, I get a 2 times a negative 27 minus a 5 times a 9 plus a 3 times a negative 3 minus a 2. So right away, I can tell you this is not 0. I'm not going to bother to add this all together. What I want you to notice is that these are all negative, right? These are all negative, so this is not 0. So the answer is no, and my reasoning is that p of negative 3 is not 0. I don't need to find out what it is. I can tell without bothering to spend a lot of time adding that this is definitely not 0, and that's all I needed to answer the question. All right, so let's look at p of p10. So p of x equals 4x cubed plus 7x squared plus 5x plus 2. Same deal, but two different factors, right? So if x minus 2 is a factor of p of x, then x equals 2 should give me a 0. So let's go ahead and plug in p of 2, right? I'm going to get 4 times an 8 plus a 7 times a 4, because that's the 2 squared, right? Plus a 5 times a 2 plus a 2. So you can do a little bit of work here, but I want to point out that we're in the same issue that we were in the last problem. All of these are positive. If you want to add them together, you certainly can. You can get that this is a 72, but you also could have noticed pretty quickly, probably at this stage, oh, hey, those are all positive numbers. There's no way they sum to 0. So the answer is no, and the reason is that p of 2 is not equal to 0, right? For the second one, right, if x plus 1 is the factor, then x equals negative 1 would be the root. So let's see what p of negative 1 is. Well, that's going to be a 4 times a negative 1, right, because the negative 1 cubed would come out negative, and a 7 times a positive 1, because you're squaring negative 1, a 5 times a negative 1, and a 2, right? So I seem to get a negative 4 plus a 7 minus a 5 plus a 2. Again, I don't care if you go straight across. If you do, you're going to get 3 minus 5, which is negative 2, and then you add 2 and you get a 0. The other way to look at it is to add the negative terms together. You get a negative 9, and add the positive terms together and realize you get a positive 9. Either way, you get a 0. So the answer is yes, because p of negative 1 is 0. All right? So that's kind of the idea there. Now we're going to walk through one more. Okay, so the remainder theorem. If the polynomial expression that defines the function p is divided by x minus a, then the remainder is the number p of a. So this gives us a really cool shortcut for evaluating polynomials using synthetic division. So let's say we have this p of x that I put here, and I want you to find p of 2. There's actually two easy ways to do it. You could do it the old school way, right? P of 2 would just be what happens if you plug a 2 in for all the x's. So it's a negative 3 times 2 cubed, so that'll be an 8, right? Minus a 6 times 2 squared, so that'll be a 4, right? Plus an x, which is just 2, plus a 10, right? So if you do this, you get a negative 24, right? Minus another 24, plus a 2 plus a 10, right? So that's a negative 48 plus a 12 if you put the negatives and the positives separately together, and you get negative 36, and that's great. Okay, so that's one way to find p of 2. There's another way to find p of 2. If you did synthetic division with the root 2, or that number 2 that you have here, right? Do synthetic division with 2. I didn't mean root as in square root of 2. Anyway, and it's not a 0 of the polynomial. So basically, I didn't mean to say root at all. Anyway, so then I write the coefficients across the top, right? Negative 3, negative 6, 1, and 10, right? Notice I'm not missing anything, so I don't need a placeholder, right? So if I drop the number straight down, I get a negative 3, right? 2 times negative 3 is negative 6, and then I add straight down to get a negative 12. 2 times negative 12 is a negative 24, right? And then I add straight down to get a negative 23, right? 2 times negative 23 is a negative 46, and I add straight down, oh look, there's my negative 36, and that is p of 6. Sorry, p of 2. Come on, brain. P of 2. Sorry, people. I don't know what time you're watching this, but my brain says that it's very early right now. Okay, anyway, so I get 36. So either way you choose to do it, completely fine. Doesn't matter which one. It's just a nice, convenient shortcut. I tend to pick synthetic division to evaluate a lot more often in my own personal work. When I'm trying to evaluate functions, I tend to pick synthetic division over plugging in, but certainly either works. They're exactly the same concept, they just work differently. All right, so The factor theorem and the remainder theorem together lead us to how we can use synthetic division as a factor. Recall that if x minus r is a factor, then p of r is 0. Also recall that p of r is the remainder when we divide by x minus r. So if we use synthetic division to get a remainder of 0, we've found one of the factors of something, and the quotient is all the leftovers, and we can continue factoring that. So it makes a ton of sense, as a side note, that when we divide by a factor, we get a remainder of 0, because that's really what it means to be a factor, right? They divide evenly into the, that it divides evenly into the dividend, right? So like 3 is a factor of 24 because 24 divided by 3 is 8. No remainder, just 8. But 9 is not a factor of 24 because 24 divided by 9 is a 2 with a remainder of 6, so it's not a factor. Anyway, kind of cool side note. So we're going to move on to the next video, which is going to be using synthetic division to factor.